Hi, I'm Jim Watson, and I've been a SAS trainer since 2003. A while ago, I delivered a webinar on date and time values in SAS. Here is some interesting content from that webinar. I hope you enjoyed this clip. Have a great day. Now, in this case, I've got two quick demonstrations to do. In this case, I'm actually working on how many years has it been since the SAS Date epoch, using the appropriate functions there. So INTCK, that just compare those two dates and tell me how many intervals are in between, using the discrete method for most of them. Although I have actually included a case where I've used the C for continuous method when it comes to weeks. That's the only case where it's very likely to change. And here, with these 4 lines of code, I'm actually calculating using the current date as my beginning date, going back 1 year in time, because year is my interval and -1 is my increment. Remember, the increment must be an integer. So B for beginning should be the first day of the previous calendar year, M for the middle, E for the end, and S for the same day, or at least as close as it can get. And I think you guys might appreciate this line of code right there. This is not covered in any training course, but it is if I teach it. The year.7 interval is very useful in various parts of Australia because it assumes that the years begin in July, which is a fancy way of saying a financial year. So what you're seeing there is the reason why SAS lacks a financial year function, because no one can agree about when they actually start. So, but if you know, you just add the right number. So yeah, in New Zealand, that might well be 4. I'm not sure when your financial years exist there, but it's whatever you say it is by using the shift index. So let me give this code a run so we can see the outcome there. Let's zoom in on you. Yeah, as you can see, when INTCK did return an integer value, as it always does. So that's just working out, it's been 65 years since the SAS epoch. Notice how week discrete is 2 and week continuous is 1. Let's have a quick look at the code for that. That would be because in this time frame that I have chosen, there are in fact 2 Sundays. So I would argue week discrete would be correct, that's the default, because it counts Sunday as the start of the week. So why then, when I changed the arguments and made it C continuous, did I get 1 less value? That's basically because in this case, the week begins on the first date. So in this case, 23rd of May, I believe was a Friday, but as far as the continuous method is concerned, it is the beginning of the week. And because of the relative lack of days between them, it only actually saw 1 week interval, thus resulting in 1. So as you can see here, when I scroll over, that's the first day of last year, the middle day of last year, the end day of last year, and the same day of last year. See, that's perfectly safe calculation. And if you're trying to work out anniversaries any other ways, I would advise against that. And finally, this value you see right here should be the 1st of September, 2024. That is the beginning of the current financial year. To do that, I had to use the interval of 0, because I did not actually want to increase or decrease the period. I wanted the current financial year, so the 0 increment would be appropriate. And I went for B for beginning because, well, you have to choose something, and B for beginning is the default. So by using that calculation, normally it's very simple to deal with financial years. As a matter of fact, an idea for a future presentation, you could even write your own format to do it, but that would require you to attend Programming 3. More of that one coming up. Very nice. And now, in this case, a little bit of bonus material for you there. I figured financial years can be a vexing issue. I found a function in the SAS system that deals with that, called n week day of month. It returns the nth day of any given month. You need to give it 5 arguments. The first argument is the n value. That's normally a number from 1 to 5. 1 would indicate the first of the day of that month. 5 would indicate the last. There's my actual date. Day I've chosen. 1 indicates Sunday after all. That's when daylight savings begins. And as it turns out, daylight savings begins on the last month of month 9, otherwise known as September. And I've also included the current year. Now, of course, Australia's got to be a little bit different. We actually begin daylight savings the following week. That would be the first Sunday of October. So I've specified 1 for the value of N, 1 representing Sunday, 10 representing October, giving it the current year. Fortunately, we both use the same method for calculating when daylight savings ends. That's the first Sunday of April, but of the following year. So let me just run this code. So there you go, be warned. Daylight savings begins this year on the 28th of September, that's a Sunday, as is the 5th of October, that's when the Australians begin their daylight savings, but we both complete daylight savings on the same date, 5th of April 2026. So yeah, let's just say, and this is only a brief sample of some of the many very useful SAS functions. You have plenty more, I assure you.